To compute a difference quotient, you'll first need to commit to memory the formula that allows us to do it. The difference quotient formula that we use every time is f of x plus h minus f of x. Take all of that and divide it by h. This just means on our function, we'll first substitute x plus h for all of the x's. Then we'll subtract the original f of x, and we'll divide it all by h. So I'm using this formula on this expression for the first one. Now, what the first part of our formula tells us to do is anywhere there's an x, let's put x plus h in its place. So the 2 that we had here is the 2 that is there. Instead of this x, let's replace it with x plus h. Then let's bring down the plus 1 that was on the back. All I've done so far is the first part of the top, taking x plus h, putting it in for all of the x's. The back part of the top says subtract f of x. It's the opposite of f of x. What's the opposite of positive 2x? That would be negative 2x. What's the opposite of positive 1? That would be negative 1. We'll take all of this and divide by h. Now, I see already that these 1's will add out. There's no need to bring them with us if they're going to add out, so you can go ahead and throw them away. Distributing the 2 here gives me 2x plus 2h. We've thrown that 1 away. Bring down the minus 2x, and we've thrown the other 1 away as well. All of this is over h. What do you see now? Looks like the 2x's are going to add out, and the only things that are remaining have h's attached to them. This is one trick to know that we're heading the right way. When we get to the next to the last step, only things that have an h will be remaining. Now, since those things are multiplied together, I can cancel these h's out, and our difference quotient is 2 for this particular problem. Did you see a 2 when we started off? Keep that in mind. Let's try another one for a difference quotient. Here's our formula again. We're going to use it this time on 3x minus 2. So the 3 that is here is the 3 that I've written there. Instead of this x, let's substitute x plus h in for that x. Now let's bring down the minus 2 that was on the back. All I've done so far is the first part of the top, putting x plus h in for all of the x's. Now let's do the back part of the top. It says opposite of f of x. What's opposite of positive 3x? Negative 3x. What's opposite of negative 2? Positive 2. And now all of this should be over h. Looks like, again, I've got constant values that will go away. There's no need to bring them with us. Let's distribute here. 3x plus 3h. This has been thrown out. Bring down the minus 3x from here. This has been thrown out. It's all over h. If you're going to make it to the next round, you need an h attached to you, so these things needed to go away. It leaves me 3h over h. The h's cancel, and 3 is our solution. Did you see a 3 somewhere at the start? Looks like on these things that are linear, the difference quotient solution will just be the coefficient. Remember that the word linear means that you've got something with a degree of 1, that the highest exponent is a 1. Doing a difference quotient is really just a fancy way of finding slope of a line. So since this linear equation has a slope that is the coefficient of the x, then anytime you're doing a difference quotient for something linear, the solution is the coefficient. The difference quotient of something linear is the coefficient.